All right, class. So today what we're going to be doing is we are going to be learning about polynomials. So polynomials. Basically poly meaning many, and nomials, as we've discussed in monomials, many terms, right? So this thing has more than one term. More than one term means that it's separated by an addition or subtraction. So for example, I mean, you've seen something along the lines of x squared plus 5x minus 4. That's a polynomial. How many terms? Well, 1, 2, 3. So this thing has 3 terms. All right, so there are 2 different ways to actually categorize polynomials. You can categorize, so we'll say this. How to categorize polynomials. How to categorize polynomials? First way is through the number of terms. The second way is through the degree. Okay, so let's do that. So how to categorize the polynomials? We're going to do it number of terms and the degree. So first, let's just talk about number of terms. So number of terms. I'm going to give you an example, and then I'm going to give you the actual name. So for example, if we only have one term, an example being 5x squared, the name would be monomial, which we already know. What if you have 2 terms? An example would be x squared plus 5. That is a binomial. The last one, 3 terms, 5x squared minus 2x plus 7 is called a trinomial. All others, so anything above 3, so like 10x to the 5th minus 4x squared plus 6x minus 5. That's 4 terms. We just call it the generic polynomial. Okay, so pretty much though, the 3, there might actually be names for the number of terms being above 3. But basically, though, all we care about is monomial, binomial, trinomial, and then from there on, polynomial is fine. So this is by the number of terms. Now, what about the degree? Well, the degree is kind of a different idea. The degree happens to actually be counted through exponents, in fact. So here we go. So, categorize polynomials by degree. Okay, so here it is. How do we categorize the polynomial by the degree? Well, first thing we do, again, what is the degree? We will give an example, and then we will give the name. Okay, so what if it is a 0 degree? The example would actually be just a simple number, 7. The reason that it's that 7 would be an example of a degree 0 is that if I wrote, so I'm going to kind of go off to the side here, if I wrote 7x to the 0, hence the degree, or the exponent of x is 0, anything to the 0 power is always just 1. So this thing actually just equals 7. So that's why 7x to the 0 is just really 7, and that's why a degree 0 polynomial is just the number 7. Obviously, any number would do. The name is called a constant because this is a constant number. It's not a variable. It doesn't change, right? So this thing is a constant number. So we just call it 7, or the example would be 7. The name is just a constant. So the degree, what about first degree, or 1? First degree, an example would be 3x plus 4. Now you notice this also has a constant term in it, but we don't name the polynomial by what it has after its highest degree term. This is the highest degree term, not this. So we call the entire polynomial by its highest degree term. This, by the way, has an understood x to the first. You never actually have to write a 1 as an exponent. We just understand it to be there. What is this guy's name? Well, I'll ask you this. If I were to graph 3x plus 4, okay, if I were to graph 3x plus 4, what sort of graph would I come up with? Well, if you remember from Algebra 1, you would come up with a line. And so the name of this polynomial is called linear. So this is a linear polynomial. In fact, this is a binomial, because it's got 2 terms, linear polynomial. Excellent. Let's do another one. What about 2? An example would be 5x squared plus 2x minus 4. Something along those lines. Notice, yes, it has a linear term. Yes, it has a constant. But these two things don't matter because this is a higher degree. And so we call this, well, let's think about the graph again. It is called a quadratic. So, for example, you probably ran into this word before. You probably solve quadratic equations. Like, so if I set this thing equal to 0, this would be a quadratic equation, and you could solve it. So yes, this is called a quadratic. So when it's a second degree polynomial, you can call it a quadratic. What about a third degree? A third degree is going to be, let's do an x cubed minus 5. So notice, pretty simple, really. I could just, I only have 2 terms. This is a constant. This has 3 degrees, so we only call it a third degree polynomial. This one is called a cubic. All right, let's do a fourth degree. So maybe 3x to the fourth minus 5x to the third plus 2x squared minus 7x plus 5. This is notice how this thing is 1, 2, 3, 4. This has 5 terms. So this would be a 5-termed polynomial, right? We would just call it polynomial because it doesn't have, once you get above 3 terms, we don't really have a special name for it. So this is just 5 terms. But since it is a fourth degree, what would we call it? We actually call it a quartic. If you notice how many, this portion, quart, is actually, you might recognize it from how many cups are in a quart, right? 4 cups are in a quart. So quartic means 4 oftentimes. So that's what we call it. 4. This is pretty much as I'm going to actually ask you to know. And in fact, I would actually probably only go down to about 3. 3 is pretty much the normal. However, there are many more names, so we can kind of go over them. Fifth degree polynomial is actually called a quintic. 6 is a sestic. 7 is a septic. 8 is a octic. 9 nontic. 10 destic, I think. I'm pretty sure that's right. And then after that, it doesn't really matter. In fact, it actually doesn't really matter after 3. So you will never see any of these again, but they're just kind of a fun little word. So you can, if you remember those, maybe you can bring it up at a party once this quarantine thing shuts down. So you go to a party, you pull out these words, maybe make some friends. They can think of you as a real nerdy person. It'll be great. Okay, let's move on. So that's how we can categorize polynomials. Let's talk about how we are going to simplify polynomials. So, all right. So first, let's talk about simply adding and subtracting. Adding and subtracting. You've already done this. This is just a review. So let's talk about adding and subtracting. So for example, what if I said I have x squared plus 3x minus 5? Okay, I'm going to take this second degree trinomial, right? And since it's second degree, this is a quadratic. So this is a quadratic trinomial, and I'm going to add it to, let's just say we'll go with x squared minus 3x plus 4. So we're going to add it to another second degree trinomial. Well, what you can do is you can only add like terms. Like terms are things that have the same degree. So for example, I can take this x squared and add it to this x squared. So I can combine these two like terms. So when I add two things that are the same, I get the exact same type of thing, I just get more of them. So what type of thing is this? It's still going to be x squared, but I now have, well, I had one over here, and I have one over here, so I've got to have 2. So this is 2x squared. All right, I have the next type of thing, which is just an x, right? So I got 3x and negative 3x. If I add those together, I don't get any. I can write that as 0x, but I don't even actually have to write that at all. But let's just write it as 0x for right now. Then I have negative 5 plus 4, which we know as negative 1. So our actual answer is 2x squared minus 1. One way you might be able to remember that you can only add like terms, and when you add those like terms they don't change, is think about this in dimensions. For example, if I measure something, right? Let's say I measure something and it's 2 inches. And then I measure this extra little piece, and this piece is 3 inches. Well, when I add these two things together, what do I get? I get 5 inches total, right? What did I do? I took something that was a type of thing, inches, and when I add them together, it remains inches, right? It doesn't change. Now, what if I took a length, 2 inches, and then I added it to something that actually isn't a length at all anymore? This thing I'm going to write as 3 inches by 3 inches, which, by the way, is 9 inches squared, right? It's an area. So if I take 2 inches and I add it to 9 inches squared, well, I can't add those two. This is a length, this is an area. It's a completely different thing. So since it's a completely different thing, I cannot add them. And for that exact reason is why I cannot take x squared and add it to 3x. They are completely two different things, so they cannot be added, right? So there you go. All right, let's go on and do, let's do a subtraction. So what if I had 3x squared minus 4x plus 6. And I'm going to subtract maybe 5x minus 4. Okay, well, since I'm subtracting, and this is in a parentheses, that means I actually have to subtract everything that's in this parentheses. So this thing is grouped together, and I'm subtracting the entirety of it. One way to kind of simplify things is to basically say, well, since I'm subtracting everything in here, why don't I just subtract this by itself and then go around and subtract the 4 by itself? Well, actually, the negative 4 by itself. So I'm going to subtract both things separately. And the way I do that is I just rewrite everything by removing the 2 parentheses. But then when I write this, I'm going to subtract the 5x because it's asking me to subtract the 5x, but I'm also going to subtract the 4. And in fact, I'm going to say, well, I'm going to subtract the negative 4, right? I'm subtracting the negative 4. So if I subtract the negative 4, what happens to a double negative? Well, you probably already know this. It becomes a positive. And now we just have to combine like terms. There's only one x squared term, so let's keep it. There are 2 x terms, here they are. They combine to be a negative 9x, and there are 2 constants, which combine to be a positive 10. And so our subtraction here ends up being that. So that's pretty much as complicated as adding and subtracting get, though. So it's not very difficult. I think you already have, from your Algebra 1, you probably have already experienced this, so you should be good. So good luck with the adding and subtracting of polynomials. We'll come back with multiplying them in a second.